this morning or this afternoon. Compute the clicking pointage you have less than 85% answer. And so let's get to that, and then we'll get back to energies after this little calculation. So click questions you answer every day in lecture. Now, we're going to so let's get going. All right, so here's your grades. Here's the home page. And if you have looked at it in the past 15 hours or so, you'll notice that there's some new grades. And if you go into the grade, this is my demo. But in this regard, it does. The grades page looks fairly normal. Down below are the I've filled out all the clicking data up to Tuesday, so it's all updated. And if you look at it carefully, what we want to look at is the answers. So this indicates the number of answers that you clicked in on lecture 5. So over here, it indicates this test student answered 1 out of 4 questions on that particular day. And then you look a little bit further down, L6 answers. And you just keep going down, L7 answers. Now you skip over the L7 correct, L5 correct, all that. And I'll explain that after we do the participation points. Anyways, L8.1. And so forth. Now, I forgot to take this out. You guys definitely do not have to worry about. Let me pause. So I want you to, this is configured for the morning session, and I told them no, don't pay any attention to L8.2. But you guys, yes, I want you to pay attention to that. There's a couple lectures where we had a different number of questions answered. So lecture 8 and lecture 12, you guys had a certain number of questions, and the other class had a different number. And so that's why down here, if you look at it, L12 is bifurcated into 2 sets of data. One set for you guys, one set for the first period class. So you guys are L12.2. Anyways, you go down through here, all the way down to L15 answers, and you just add up your points, the number of answers that you've, the number of questions that you've answered. So for the morning student, it would look like this. Okay, L5 answers, he answered 1. L6, he answered 1. L7, he answered 1. L8.1, 3. L9 and so forth. Now, an afternoon student would look like this. Go ahead and write this one down as well. Actually, let me go back to the other one. Here's the morning one. This we're going to work out this example. 23 out of 31 possible questions. So he's got 1, 1, 1, 3, 2, 3, 6, 2, 4. Total of 23. And this is the demo student account. Your numbers will look a little different. You might have all points every day for all these lectures from L5 to L15. Okay, here's an afternoon student. 22 out of 28 possible. So for this class, the possible answers are 28. The total possible answers is 28. Morning class is 31. Here's a table that shows you that. Okay, so Now, as I've mentioned before several times, the way that we grade participation is we expect 85% participation, and that counts as full participation. All right, so that gives you some leeway to miss one or two lectures. Now, for section 1, they had 31 answers possible as of Tuesday. All right, so 85% of that is roughly 27 or more. If you had 27 or more answers in section 1, you get 25 points automatically out of 25. Now, for you guys, it's a little bit different. For you guys, we've only had 28 questions from lecture 5 to lecture 15. So for you guys, the 85% threshold number is 24. So if you've had 24 questions on the books that you answered, ding, you get 25 out of 25. No questions asked. And that is where you want to be. You want to be down here at the 85% level. And I'm happy to say that almost everybody in this class is there. 60-something% of you are at 25, and like 74% of you are 23 or out of 25 or higher. So everybody's doing good, clicking wise. Okay, and a couple things I want to point out about this particular slide. As I've mentioned before, students come up and say, Dr. B, I missed lecture, but I don't have my clicker, but I wrote down my answers on this piece of paper. Can you use this? And the answer to that is no, I never take that because it's a mess. And this is because we have an 85% leeway factor. So this means, if you look at this, in this class, we've had 28 questions. All you have to answer is 85% of that, or 24. So that's roughly one lecture. We're halfway through the semester, roughly. So, as I say, one or two lectures, if you miss, for whatever reason, dentist appointment, and then another day you forgot your clicker, you should be all right. Unless it's one of the lectures like Tuesday when we had 7 questions. Okay, but you want to make all your lectures if you can. Most of you are doing that, and most of you are doing really good. All right. Now, I want to do a sample calculation with the morning class numbers. Okay, so you guys can do some. So go ahead and write it down, this calculation that we're going to do. And take notes on this very carefully. And you guys will do a similar calculation based on 28. So first of all, you add up your answers, and then you add up the total possible answers. And then once you have the total possible, you figure out, okay, what's 85% of that? Okay, and you've got to have more than that 85% number. All right, as I mentioned, for this class, it's 24. If you have 24 or more, you're 85 or higher. Okay, so if your answers are larger than 85%, automatically, bing, bang, bow, you have 25 out of 25. No further calculation necessary. Okay, and a huge majority of you are in this situation, 25 already. All right. Although it's only halfway through the semester, so things can change. But if your answers are less than 85%, this is the tricky part, so take careful notes here. All right. Now, first thing you do, if your answers are less than less than 85%, or less than 24 in this class, so if you have 23, or if in the other class you have less than 28, then you have to first calculate your percentage. Okay, so for the morning example, that particular student had 23 out of the 31 questions. Now that works out to 74.2%, approximately. All right, and you can, if you're going to need your calculators anyways, get them out and re-verify these numbers if you want. Yeah, 23 out of 31. That's 74.2%. All right, so they're less than 85%. We got to do some proportionality calculations here. All right, so that's the first step. Calculate your percentage. Now, second, divide by the leeway factor, 0.85. All right, so you take your percentage and divide it by 0.85. All right, and so in this example, it would be 0.74 divided by 0.85. Okay? And this is where the proportionality starts to come in. Then you multiply that number by 25 points, and this is where the points come from for your semester grade. Okay, because you're going to get 25 out of 25, or maybe fewer than that. This is where the points come in. So you go like this, and basically you're solving this proportion. So write this proportion down really carefully in your notes, because I'm going to ask you a clicker question in just a second. Get your clickers ready. And what we're going to do is calculate that. So you basically solve this by cross multiplication. Multiply by 25. Okay, and then you round up. And I always round up on this and also on homework, just for convenience, just for the good of humanity. Give you guys a break. So even if you come in at 22.001, I round that up to 23. Okay, so it just makes things a little bit easier. So as I said, the three things that you have to do: calculate your percentage, divide that by 0.85. Okay, that's this quotient. And then take that quotient into this proportion and then solve for your points. Okay, so our clicker question is, how many points in that example would that student get? All right, what is the whole number of points for that student? So type in a whole number and hit the send key. And there's the proportion that you have to work. All right. Yeah. Because lecture 8.2 and 8.1 had different, the morning lecture had a different number of clicker questions. This is lecture 8.2. Or this is section 2, so you don't have to look at anything under 8.1. Right? So if you have lecture 8.1 numbers, that means you're in the wrong section, or your clicker's messed up or something like that. You're looking at the grades page right now. Okay. All right, 30 seconds. Yeah, like the fiasco day when we couldn't get the display going up here. I couldn't ask as many questions as I wanted, so. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, let's see what you guys answered. Yeah, pretty good. 22, 97% of you got it. And so that particular student would get 22 out of 25. Now let me add one more thing, and that is, if this happens to be you, even if you're in this situation where you're 22 out of 25, you're starting to, forget, you've got bonus points already in the books. Registration. Okay, so if that student had 3 early high school registration points, then and we'll have other bonus point opportunities, special study groups, stuff like that, through the semester, saying? So even if you're in this situation, this plus your homework grade add up to the midterm. So if you keep this up at 25 out of 25, and that's like 60-something% of you, and you also take down 25 out of 25 on homework, that's like taking 50 out of 25. That's and then that counts as great for the job. It's a nice bundle of points. And I don't want to say it's easy money, but it's fairly easy to keep it up 25 at 25. So in general, here's the calculation that you've got to do. Your percentage, whatever it happens to be at any given time, divide by 0.85, and then solve for the numerator on the other side. Cross multiply by 25. Forget to round up. And that will do it for your pointage. And you can do that at any time in the semester. Question. You'll be able to do calculation. And I know what everybody's looking percentage or percentage pointage is right now. And I know that 60-something% of you have 25, and it's 25 if you stop going to class. But if you hold class, you're going to continue taking 25 out of 25. Now, let me pause for questions. Okay, let's keep going. Last time we were talking about kinetic energy of a basketball in free fall. Different mass in class than we have for homework. Homework, it was 0.600 kilograms. In class, it was 0.620. But we're going to work out some more stuff. And I know a few of you were getting your brains burned up to the crisp with some of those calculations, figuring out the speed. We're going to do that now. And what we're going to do is do that on the document. The way that I'm going to do this is I'm going to document can, and then when I get back to my office, I'll scan it to a PDF and I'll embed it in the movie. So instead of seeing this slide, you'll see the PDF document. And it will work out pretty well. So I'll keep recording, and I'll embed the PDF scan, and that'll be good. Let me switch to the document. All right, great. Now let me get the calculator. Push this forward just a little bit. Okay, now I can see. Now, so what we're going to do today is rework some of the features of the problem. Basically, three elevations of interest: 2.5 meters, 2.5 meters, and 0 meters. What we're going to do now is make a table that lists the elevations and the energy values. So the first column of my table is going to be the position on the y-axis in meters. And in this homework problem, and then the floor level 0.00 meters. Okay? And then I need 3 more columns, one for the kinetic energy, one for the GPE, gravitational potential energy, and one for the total energy. First, GPE in joules. Fourth column, total energy in joules. Now, as a side note, the weight force for this basketball. Can you see this? I can't. Yeah. Okay. 5.88 newtons negative. And you kind of know that in order to work out this problem. It's in pretty much everything. All right. Now, the problem started with the basketball averaging the highest point of the turning point in its motion. It goes up and then it turns, it comes back down. It drops straight down from averaging. What that means is at averaging 3.500 the GPE is 0.600 kilograms times positive 9.8 meters per second squared times whatever the y coordinate is. And so we'll calculate that right now for 3.5. Amari, you can't see this. I can't really see it. You see what I type in? Can you see that? Oh, brother. All right. Well, you're gonna have to walk by faith, if not by sight. So I'm gonna calculate 0.6 times 9.8 times 3.5, and when I do that, I get 20.58. Anybody remember that from last night? Can you read that? That's pretty bad. Okay, now we're about to do a sweeping cavalry maneuver through this table. Because now we've got potential and kinetic energy specified. We know what the numbers are. So automatically, now what the total energy is, 20.8. And once I get it in that column, I know it in any column. So let's go down to the next row, or excuse me, any row. 20.58. All the way down. Or, as we did in office hours, ditto marks. Okay? 20.58. Now that's all the way down. Any column, any row, even if I ask you, like 2.7 meters, 20.58. Any row, any elevation. All right. Now, down here at the floor, why is 0? All right. And therefore, last cavalry charge, what does the kinetic energy have to be? 20.58. So you see, once you get that total energy, you can start making a lot of quick deductions and decisions. Now, the homework was about this row. What is the kinetic energy and what is the speed? That's what we're going to calculate now. To get the kinetic energy here, I need to know potential energy here. That's a function of y. So let's see. So let me clear. Okay, so 0.6 mass times 2.5 height times 9.8 equals 14.7. Anybody remember that from last night? Okay, 14.7 for the GPE. Now this one here has to add up to, or this one and this one, these two have to add up to 20.58. So all you got to do now is subtract, and I'll do that over here to the side. 20.58 E minus GPE, so minus 14.70 equals kinetic energy at that position. All right, so let's see. 8 minus 0 is 8. 15 minus 7 is 8. 19 minus 14 is 5. 5.88. Anybody remember that from last night? Okay, so there's my kinetic energy. So there's one of the answers to the questions. Now the brain burner was, all right, what's the speed at that level? I'm going to calculate that next, but before we do, let me pause for questions. All right, let's go. Getting V. Here we go. Move this up a little bit. And we're going to use this information here. Now that's a kinetic energy. You just brought soda pops for everybody in the back table? Is that? It's nice. Somebody just walked in and okay. So we're going to get V. Now, what we're going to do is we're going to use the kinetic energy information. And we know that that's 1/2 mv squared. And that's going to allow us to figure out v squared because we use the mass. It's 0.600 kilograms. And hey, you guys, I'm going to write this as 5.88 kilogram meter squared per second squared. That's definitely a joule. And the reason that I'm doing that is because I want to cancel. And what I'm going to cancel is kilograms. If you look at this carefully, you'll see that there's kilograms on both sides of the equation, left and right. So they can cancel out. All right, which is nice. So Deborah, here we go. We're going to cancel here and here. And now my next step, and I'm going kind of step by step so that I don't lose anybody. Those of you that have had trig and calc, maybe a little bit ahead of everybody, but we'll just kind of go nice and easy, step by step. We'll just put it together. 50-50. Okay, now I'm going to change this into 0.30. 0. And notice I don't have any kilograms there anymore. They're out of here. Okay, but I still have v squared over here. So now I want to get v squared by itself. I can clear it by dividing both sides by 0.300. So I'll write that down here. Divide by 0.300. And over here, divide by 0.300. And hey, look, this is nice. Meters squared per second squared. That's the units of a square of a speed. So that's good. And now I just got to do 5.88 divided by 5.88 divided by 0.3, 19.6. Anybody remember that from last night? Okay, so that's equal to v squared. Okay? And so now you just got to square root it. So v is the square root of that. And let me set square root. Second answer. 4.427, 4.43 to the nearest hundredth of a meter per second. So there's your answer. And that, my wonderful students, is how you do it. Pause for questions. Times g as a positive number, and then y, or delta. Okay, so for this, it's just 6 times 9.8, and that works out to 15.7. Do you have your calculator with you? Okay, so borrow somebody's calculator and you can verify that. Another question. Let's do some more questions. Yeah, it's fair. It built in here so that in case I needed 2 pages on the dot cam, I could do that. But and it's true. You're a hammer on the moon, so you're all inside the forward mass. We're going to take a look at a hammer falling on the moon. All right? So, for the moon, gravity is weaker at the surface of the moon than it is on Earth. The gravitational acceleration is only 1.62 meters per second squared, negative. All right? And basically, it is because of the size and mass of the moon. The mass of the moon is only 0.123 of Earth's mass. That's 1.23%. 1.23% of Earth's mass. So the moon doesn't have a lot of mass. And its radius, let me move this back a little bit now. Its radius is 0.2725. So it's 27.25% of the radius of the moon. So it's smaller, not as much mass. So gravity is weaker. And if you look up on the internet, if you go into Google and you type in planetary fact sheet, the first thing probably that will pop up is a NASA planetary fact sheet that has all the planets. And you can look at the surface gravity of the moon, Earth, Venus, Mercury, Mars, all the planets, and many of the moons. And because we know it all. And this is a normal value for one of the terrestrial planets. Now, the moon is not a planet per se, but it's roughly the size of it could be a planet if it wasn't orbiting Earth. It's roughly the right size. It's kind of small, but it's on the small side. But Venus has a surface gravity similar to Earth. Mars is a little bit weaker than Earth, stronger than the moon. So you can look it all up. Question? Gravity is down. Negative sign means downward. And remember, when we're working on energies and stuff, you got to pay real close attention to downward and upward on your trajectories and stuff. But the size of it's pretty small. It's 1/6 of the gravity on Earth, basically. And so what that means is that, yeah, they can really jump. They can really sky up there on the moon. And if you look at the Apollo astronauts, they're taking these big, long leaps. You know, they can't really do much in those big spacesuits. But they can really, they can run like the wind up there on the moon, because they could just take a stride, and it's like about 5 yards before they touch down again, and then another 5. So it's like, 20 league boots, if you remember those fables from when you were a little kid. So that's the moon, the hammer. We're going to put the hammer down, and here it is, 0.703 kilograms. And you may think to yourself, Dr. B, is that really a official NASA hammer? No, it is not. It is from Granger.com. Just looked up hammers. Granger. So hopefully you've written down those two numbers, because I want to do another clicker question. Hit the refresh key on your calculator. Now let's see if you guys are sharp enough to work for NASA today. All right, question number 1. Boring. What is the weight force of the hammer on the moon? Hopefully this is boring. Go ahead and calculate that and make a decision. Although I predict I'm going to catch a few of you napping. Yeah, we're going to be doing weight force and F equals MA from now until the end of the semester. Just the way things go. And while you're doing that, I'm going to drink some water. 15 seconds. This should be easy as walking through the park. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Zip, zap. Let me see what you guys voted for. Yup. Correct answer, 1.14 negative. That's MG on the moon. I caught 15 of you napping over here on 6.89 and negative 6. That's a good weight for us, but not for the moon. That's the weight for us on Earth. So if you voted for that, don't let me catch you napping that way on the test. That's all I have to say. Or on the homework. Oh, did I say homework? Yes. Hit your refresh key again. So you guys got the weight force, 1.14 newtons. All right, now let's see if you can figure out the kinetic energy. And this one, I'll give you some minutes. And look at the table we just worked out on the document can. Talk with your neighbor. And you just kind of coordinate and think. Remember, talking to a neighbor helps you to think. Thinking is what helps you to get a good grade. And crush my exams. So the astronaut drops the hammer from a small platform on the lunar module, the LM, from a height of 2.2 meters above the surface of the moon. What's the kinetic energy halfway down? Just take your time. Plenty of time. How come you have that Wisconsin t-shirt? You were wearing a different t-shirt last time, Tuesday, right? It said something else. Yeah. Yes, I did, and so that's why I noticed that today it's regular. Is that where you're from, Wisconsin? Where? Kenosha? Up, I got it. Huh? No, but my brother used to design engines for Renault. And they had a big factory. Well, Chrysler had a big factory at Kenosha, and then Renault used it for making engines and stuff. No, I've driven through Wisconsin a couple times, hitchhiked through and stuff. I never really spent any time there. I'd love to go up there. I'm a huge fan of the Green Bay Packers. As normal people should be, right? But no, there's all these Dallas Cowboys fans and New England Cheatriots. I did live in Minnesota for a while, but you know my great-great-grandsters immigrated from Germany and landed. The first place they landed settled was Wisconsin. Then Chicago, yeah. Then they went, well, I think they came through Ellis Island back in 1848, but then they went to first to Wisconsin, then west to North Dakota, and then to Illinois. And so, like, my grandpa was born in Illinois, but his dad was from Wisconsin. Yeah, Germans. Yeah, my grandpa was a math professor at University of Minnesota, but his dad and his grandpa were Lutheran ministers from the old country, from Germany. So, tons of those guys out there. Swimming in Lake Superior once. My brother and I were driving our vehicles around the north side of Lake Superior. We stopped at this place. Oh, it was cold. Oh man, we got out of the water, we were red like lobsters, you know. It was so clear. It was just perfect. Where I grew up in New Jersey, forget about it. You jump in the river there, a lot of places, you're going to come down with diphtheria or something, you know, typhoid fever. 25 seconds. Seconds. 26 is wrong, and so what I want you to do carefully, don't, when you're doing your calculations, don't round off until the very last your number, your answer. Okay, so keep all the, so that's why I say, keep all the digits on your calculator and just use them in the next step of the calculation. And then at the very end, you'll still have all your digits, and then you decide, okay, 1.26 or 1.25, okay? And because that's a round-off error. It's not bad. It would be partial credit on the test, 2 out of 3. But try to do your best. All right, and you can do your best again. This question, here it is. It's verbal. It's not on the screen. What is the speed? What is the downward speed? So give me a downward speed to the nearest 0.01 meters per second. Downward, so a positive something point something something. 0.01 meter per second. So it's going to be something, point something, something. Okay? And it's good. Just give me the positive number. I didn't start the question. Okay, now you can send it. Type your answer in and send it. Alright, here they go. see what you guys got. Come on. Oh. Whoa. You guys are geniuses. All right, I'll call NASA up, see if I can get you guys jobs. Homework 13 will be available by lunchtime tomorrow. You are dismissed. Next week we'll talk about